Hi everyone, I'm Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I'd like to share on the topic vector differentiation. This comes under vector calculus. Vector calculus can be classified into two categories, vector differentiation and vector integration. So we know that already the differentiation and integration on scalar functions. Similarly, we do the differentiation and vector integration on vector functions also. And this will see how so what is the vector differential operator? So we know the vector, it contains I bar, j bar, k bar, and scalar functions means it is a only function of x, y and z. And in vector point functions, it will have the function of x, y, z. F bar of x, y, z is a function with the vectors I bar, j bar, k bar. So that all you have studied in the previous classes. Now, I'd like to define the vector differential operator. The operator del or nabla is called as vector differential operator, and it is defined as del is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. The vector differential operator is defined as I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z, and the notation we use is it is called del or nabla, which is used to show the vector differential operator. It is a symbol and we call it as del or nabla. And this operator del can be applied on both scalar point functions and vector point functions. Del can be applied on both functions. Suppose in this vector differentiation, del can be applied on both vector point functions, that is scalar functions phi of x, y, z, and on vector point functions f bar of x, y, z. We see how to operate the del on scalar functions and on vector point functions f bar of x, y, z. Suppose if del applied on scalar functions, that can be defined as a del phi, then it is called as gradient of phi, that we define, and we do some applications on gradient of phi that have physical significance. And also del can be applied on both vector and scalar. So suppose if you apply on vector point function as a dot product, then it is called del dot f bar. And suppose if you apply del on f bar as a cross product, then it is called del cross f bar. And del dot f bar is defined as the divergence, and del cross f bar is defined as curl of the vector point functions. In this vector differentiation, we have three topics. One is gradient, and the other one is divergence, and the last one is curl. And in this topic, we study all the three categories, that is called gradient, divergence, and curl, and how to operate on functions, different functions, vector and scalar, with using of the del operator. Del is called the differential operator. In scalar functions, we use the differential operator as d by dx or dou by dou x, like that. So in vectors, we use the del operator. Del is defined as I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. And del can be applied on both vectors and scalars, both vector and scalar point functions. Scalar function means only the surfaces f of phi of x, y, z, f of x, y, z, like that. Now, what is the gradient? So now I would like to define the gradient. The gradient of a scalar function phi of x, y, z is denoted by grad phi. Grad phi means it is gradient of phi, and we write it as a del phi also. And it is defined as grad phi or del phi is equal to I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of phi. That is I bar dou phi by dou x. On operating dou by dou x on phi, you will get dou phi by dou x plus j bar into dou by dou y on operating phi, you will get dou phi by dou y plus k bar into dou phi by dou z. So this also I can write it as summation notation. This is sigma is sigma that is I bar dou phi by dou x. That means it on expanding you will get I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So here we use the notation summation I bar dou by dou x means it will give all the three terms. Now what is the gradient? So what is the use of the gradient? So the gradient of phi, the physical significance is, suppose if phi is any surface, if phi of xyz is any surface means it may be a sphere. Suppose if it is a sphere, then the equation may be x square plus phi square plus z square is equal to a square. Suppose if we have the ellipsoid, this is the equation like this, x square by a square plus y square by b square plus z square by c square is equal to 1. These are all the surfaces, three-dimensional surfaces. Suppose if it represents a phi, then if you want to find grad phi, then it will give the normal vector to the surface at any point. If you find grad phi at any point x comma y comma z, it will give the normal vector at that point. Normal vector means it is a tangent. It is a tangent to the surface. The vector which is perpendicular to the tangent vector is called the normal vector. So normal vector can be calculated by finding the gradient. That is the physical significance of the gradient. So here you can write here, you can see here, if a phi of xyz is equal to c represents a surface, then grad phi represents normal vector to the surface. So if it is a surface, then the normal vector at that point will define the gradient of phi. So that is the physical interpretation of the gradient. Similarly, if phi is a constant function, then grad phi is equal to 0. We know that if you operate d by dx on constant, this will be 0. Suppose if I bar dou by dou x, if we want to find out del phi is equal to 2, then I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the constant. So if it is a constant, then I bar into dou by dou x of constant 0 plus j bar into dou by dou y of constant 0 plus k bar into constant 0. So this is equal to 0 bar. So if you operate the del operator on the constant function, the resultant will be a 0 bar. So what is the physical significance? If phi represents any function, phi of xyz is equal to some constant, then grad phi represents a normal vector to the surface. Then you can find, if you know the normal vector, you can find the unit normal vector also. If a bar is any vector, then what is the unit vector? A bar by magnitude of a bar. We know that. Already we have seen in the vector addition and vector algebra. So suppose if phi is any vector, phi is any scalar point function, then grad phi is the normal vector. Grad phi represents a vector, it is the normal vector. Then what is the unit normal vector? Unit normal vector means grad phi by magnitude of grad phi. That here I have written, and this is denoted by n bar or n cap like that. N cap is the unit normal vector to the surface. So if del is an operator, if you want to apply on scalar function, then it will called as gradient, and the gradient represents the normal vector to the surface. And if phi is any constant function, then grad phi is 0. And the unit normal vector can be defined as n cap or n bar, and n bar is equal to grad phi by magnitude of grad phi. And the next definition is a directional derivative. So directional derivative means let phi of xyz is equal to c be any scalar point function, is equal to c be some constant, be a scalar point function defined throughout the region on some space. Then the directional derivative of phi in the direction of a bar, the directional derivative of phi in the direction of a bar is given by directional derivative is equal to grad phi dot a bar by magnitude of a bar. Directional derivative is grad phi dot a bar by magnitude of a bar. So what is the directional derivative? Directional, if suppose if it is any function phi of xyz is equal to some constant, any surface, it is some surface, either it may be sphere or some surface, three-dimensional object, then the directional derivative is defined as the rate of change of phi in the direction of a bar. Suppose if a bar is any vector, then the rate of change of phi in the direction of a bar, the surface phi, the rate of change of phi in the direction of A bar is defined as the directional derivative. So the directional derivative has the physical significance. The definition itself, it is a rate of change of phi. Directional derivative, rate of change of the surface phi in the direction of A bar is called the directional derivative in the direction of A bar. Right. So the formula for the directional derivative is grad phi dot A bar by magnitude of A bar. Grad phi, it is a vector. Phi scalar, grad phi is a vector. A bar, already it is a vector by magnitude of A bar. It is also a magnitude of A bar means what you will get, root of some x coefficient, x square plus y square plus z square coefficients, I bar coefficient, j bar coefficient, k bar coefficient whole square. And grad phi dot A bar, it will be the dot product of the two vectors. It will be a scalar, scalar by scalar. Directional derivative is some constant. And the one more point to be noticed here, the directional derivative will be maximum in the direction of grad phi. So this is the formula for the directional derivative in the direction of A bar. The directional derivative in the direction of A bar is grad phi dot A bar by magnitude of A bar. This is called the directional derivative in the direction of A bar. Suppose if you want to find a directional derivative in the direction of grad phi, in the direction of grad phi is grad phi. So instead of A bar, I have to write grad phi by magnitude of grad phi. So the directional derivative will have the maximum value in the direction of grad phi. That means what is the value, maximum value? Grad phi dot grad phi. This is a vector, this is a vector. Dot product of two vectors by magnitude of this one. And this is magnitude of grad phi. So another point here we have seen is the directional derivative. The directional derivative is the rate of change of phi. Phi is any surface. The rate of change of phi in the direction of A bar is called the directional derivative. So the directional derivative can be obtained by using grad phi dot A bar by magnitude of A bar. And the directional derivative will be maximum in the direction of grad phi. So the maximum directional derivative is equal to grad phi dot grad phi by magnitude of grad phi, that is equal to magnitude of grad phi. So these are the formulas. While doing the problems, we apply these formulas. Now I will see some examples. So once again I will repeat. So to find the normal vector, you need to calculate gradient phi. If you find grad phi, then it is called the normal vector to the surface. If you want to find the unit normal vector, then grad phi by magnitude of grad phi. And suppose if you want to find the directional derivative in the direction of A bar is grad phi dot A bar by magnitude of grad phi. And if you want to find out the maximum directional derivative, so you need to find magnitude of grad phi. And one more thing is, suppose if you want to find the angle between the two surfaces, suppose here is one sphere and here is one another surface, some surface, and let it is phi 1 and let it is phi 2. And suppose if you want to find out the angle between the two surfaces. So how to find the angle between the two surfaces? The angle between the two surfaces is nothing but the angle between the two normal vectors of phi 1 and phi 2 respectively. Suppose if I find normal vector like this, and this is called n1 bar, and find the normal vector at any point, that is the n2 bar. Now the angle between the two, this is called the angle between the two surfaces. Angle between the two vectors is nothing but the angle between the two surfaces. That is another example. If you want to find out the angle between the two surfaces, you have to find the normal vector for the first surface and normal vector to the second surface, and you have to find the angle between the two formula. Cos theta is equal to n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. So this is the formula to find the theta value. Theta is the angle between the two surfaces. So n1 bar, we know that first normal vector, n2 bar is the second normal vector. By on taking magnitudes, you will get the denominator, the product will be the denominator, and theta is equal, what is theta? Cos inverse of n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. So that is the formula to find the angle between any two surfaces. So there are several applications in the gradient. Gradient is nothing but rate of change of gradient phi. So that is the physical interpretation is the normal vector to the surface. Directional derivative means rate of change of phi in the direction of a. Now we see some examples. So how to find out the directional derivative, how to find the normal vector, unit normal vector, and how to find the maximum directional derivative, and finding the maximum, the angle between the two vectors. So these examples we see now. So come to the first problem. Find the unit normal vector to the given surface x square y plus 2xz is equal to 4 at the point 2 comma minus 2 comma 3. So you have to find the normal vector to the surface. Already it is given f or phi, whatever you assume. This is the given surface. You have to find the unit normal vector. So how to find the normal? If phi is any surface, then how to find normal vector? The normal vector will be grad phi. The normal vector is the grad phi. Then what is the unit normal vector? Unit normal vector is equal to grad phi by magnitude of grad phi at this point. So that will be the required solution. So consider the given surface. F is x square y plus 2xz minus 4. Consider the normal vector to the surface which is given by gradient of f. First, to find the unit normal vector, we need to calculate normal vector to the surface at any point. So for that I am considering gradient phi. So gradient, this is called symbol grad. Then in nabla, we call it as nabla or del. If you operate del on the scalar function, del on f, del on phi, then it is called grad f or grad phi. So now I see grad f. Grad means, del means what is the operator? Del differential operator, which is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of the function f. F is a scalar function, f of x, y, z. So that is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z. And what is f of x, y, z here is given? The function x square y plus 2xz minus 4. So now operate I bar into, operate dou by dou x on the entire function. So when we are doing partial derivative, I will show this dou by dou x of x square y plus 2xz minus 4. So when you are operating with dou by dou x, the other variables treat y and z are taking as constants. That is the partial derivative. You know that all of you. Dou by dou x of this one. So dou by dou x of x square is 2x and y treat as a constant term. Because dou by dou x means the partial derivative. We have to differentiate only the functions of x, and y and z terms treat as constant terms. So x square derivative 2x, y is treated as constant, plus 2 into x derivative 1 and z is a constant 2z, and the constant minus 4 will be 0. So what is the value? 2xy plus 2z. That is the first function on operating with, which is obtained on operating with dou by dou x on the given function, plus j bar into. So now operating with dou by dou y, this is xz term, clearly 2 constant. When you are differentiating partially with respect to y, x constant, z constant, so the derivative will be 0. And 4 already constant, the derivative is 0. Then only on applying dou by dou y on x square y, x square is constant, y is 1. So the value will be x square. Then k bar plus k bar into dou by dou z of the entire term. This is not having any z term in this, x square y. So this value will be 0. And 4, the derivative will be 0. This will be 0. And the second term will be the some value 2 into z1 2x. All of it clear? This is I bar into. So on applying the, what is the value? Here I am considering grad f at the point 2 minus 2 comma 3. That I am going to write here. So 2 minus 2, 3. So what is the value? 2 into minus 2 into minus 3. Minus 2. So 2 into minus 2. So I will explain I bar into. Here 2xy. 2 into minus 2. That is minus 8 plus 2 into z. 2 3s are 6. That is the first term. I bar coefficient. Plus j bar coefficient. What is j bar coefficient? X square. X square means 2 square. That is equal to 4. Plus k bar into, what is the coefficient? 2x. 2x means 2 into 2, that is equal to 4. So this is minus 2i bar. I will go to the next slide. Minus 2i bar plus 4j bar plus 4k bar. So this is what? Grad f. Grad f means what? Normal vector. Already I have written here, which is the normal vector to the surface f. So one part is over. We have calculated the normal vector to the surface by considering grad f at the point 2 comma some point we have at that point x comma y comma z we have calculated. So that will be the normal vector to the surface. So now the target is we have to find the unit normal vector. So how to find unit normal vector? The formula will be grad f by magnitude of grad phi. Grad f by magnitude of grad f. Both are f if we consider. So grad f is already we have minus 2i bar plus 4j bar plus 4k bar. That will come in the numerator. So what will be in the denominator? Magnitude of grad f, that is square root of 2 square plus 4 square plus 4 square. That is equal to minus 2i bar plus 4j bar plus 4k bar by root of 2 square 4, 4 square 16, 4 square 16. So this is 32 plus 4. This is equal to 36. 32. 16, 16, 32 plus 4, 36. That is equal to minus 2i bar plus 4j bar plus 4k bar by root 36 is equal to 6. Am I right? 4 square 16, 4 square 16, 2 square 4, 20, 36, root 36. So, or I can write it as minus I bar plus 2j bar plus 2k bar by 3, which is the unit normal vector to the surface, which can be denoted by n cap or n bar. In some textbooks, it will be n bar and some notations will be n cap like that. So, n cap is the unit normal vector to the surfaces. So, first find the normal vector, then go for the unit normal vector to the surface. Now, I'll see another example which is on directional derivative. So, this is the normal vector. Normal vector means grad of the given function. Unit normal vector means grad of the given function by magnitude of grad f. So, now we see another example. We'll see another example. Find the directional derivative of the function f is equal to x square yz plus 4xz square at the point 1 comma minus 2 comma minus 1 in the direction of the vector 2i bar minus j bar minus 2k bar. Directional derivative. Directional derivative means the rate of change of phi or f in the direction of some vector. The rate of change of phi in the direction of some vector a bar is directional derivative. That is grad phi dot a bar by magnitude of a bar. Already we have seen the formula. So the directional derivative here I am going to calculate. The given function already given x square yz plus 4xz square, and also given that a bar is the vector. So on which direction we have to find the directional derivative. That also given as a bar. A bar is equal to I bar. And also given some point. The point is 1 comma minus 2 comma minus 1. So the directional derivative of f in the direction of a bar. The formula is directional derivative dd is equal to grad f dot a bar by magnitude of a bar. So now first to calculate is grad f. So how to find grad f? So grad f is I bar dou by dou x. Grad f is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of f. So f is x square yz plus 4xz square. X square yz plus 4xz square. So first on operating with dou by dou x, the entire function with respect to x means x square 2x, yz as it is 2x yz. Am I right? Here with respect to x means x will be 1, 4z square will be the term. Plus j bar into with respect to y. With respect to y means x square z only, and this term will be, entire term will be 0 because The variables are here x and z square. There is no variable of y. There is no variable of y. There is no variable of y. So the value is x square z plus k bar into dou by dou z of entire term. So z here is there. So z will be 1. So first term x square y plus dou by dou z of 4x z square. Z square derivative 2z, 4x constant. So 8xz. This is the grad f. Grad f means the normal vector to the surface at any point x comma y comma z. Grad f at any point. Now I want to find the grad f at this point 1 comma minus 2 comma minus 1. So substitute x for 1, y for minus 2, z for minus 1. So I'm substituting I will calculate I bar into 2 into xyz. 1 into minus 2 into minus 1, that is equal to 2 plus 4. 4 into z square. Here 2 into, so this is 4. 2 already 2 is there. xyz, this is 2. 2 into 2, 4 plus 4. So the I bar coefficient is 4 plus 4 and j bar coefficient. So the substituting xyz, x square 1 into z minus 1. So this is minus 1 plus k bar into, what is k bar coefficient? X square y. X square y means 1 into y minus 2 plus 8 into x into z and minus 8. So this is equal to 8 I bar minus j bar minus 10 k bar. That is 8 I bar minus j bar minus 10 k bar will be the normal vector at the point 1 comma minus 2 comma minus 1. So what we have found here, it is the normal vector to the surface f at the point 1 comma minus 2 comma minus 1. Now our aim is to find the directional derivative. So we have the vector. Now therefore go to the next slide. The directional derivative of f is given by, what is directional derivative? Grad f. So I will write the formula here. Grad f dot a bar by magnitude of a bar. So grad f already we have calculated 8 I bar minus j bar minus 10 k bar. So given vector already a bar is given in the data 2 I bar minus j bar minus 2 k bar. So that you write here by magnitude of a bar, that is in the denominator. So numerator 8 into 2. I bar dot I bar is 1. J bar dot J bar is 1. K bar dot K bar is 1. So I bar dot J bar 0. J bar dot I bar 0. I bar dot K bar 0. Like that, remaining all are zeros. Only the same values. I bar dot I bar 1, J bar dot J bar 1, K bar dot K bar 1. So here 8 into 2, 16 first term. I bar dot I bar. This is the dot product in between. 8 2s are 16. I bar dot I bar 1. So 16. 8 I bar dot J bar. I bar dot J bar 0. So second term 0. And 8 I bar dot minus 2 K bar. That will be also 0. So only I bar, J bar, K bar coefficients will get the value. 8 I bar into 2 I bar will be 16. Minus J bar into minus J bar. So J bar dot J bar 1 minus 1 into minus 1, that is plus 1. And next one what? Minus 10 dot minus 10 K bar dot minus 2 K bar, that is equal to 20. So 36, 37 will be the numerator. 20, 36 plus 1, 37. So in the denominator, magnitude of A bar, that is square root of 4 plus 1 plus 4. That is equal to 37 in the numerator. Root 9 is equal to 3. 37 by 3 is the directional derivative of f in the direction of A bar. Here you find the maximum directional derivative also. Maximum directional derivative, how you will get maximum directional derivative? That is magnitude of grad f. That is square root of, what is grad f? This is grad f. 8 I bar minus j bar minus 10 k bar. So I will get the magnitude of grad f is root of 8 square 64 plus 1 plus 100. That is equal to root of 165. This is the maximum. This value is 37 by 3 only. The maximum directional derivative is root of 165. So definitely this value is more than this one. This is the directional derivative. This is the maximum directional derivative. That will be happen root of 165. So that is the method how to find the directional derivative of f in the direction of a bar. So we have seen the first problem as a normal vector and unit normal vector. In the second example, we have seen how to find the directional derivative of f in the direction of a bar. So I will see one example. Find the angle between the surfaces. Find the angle between the surfaces. X square plus y square plus z square is equal to 9 and z is equal to x square plus y square minus 3 at the point 2 minus 1, 2. So here there are two surfaces. I will do this problem. X square plus y square plus z square minus 9. This is the first surface phi 1. And what is the second surface? Phi 2 is, and x square plus y square, x square plus y square minus z minus 3. This is second surface. Now find grad phi 1. Grad phi 1, what it is? Normal vector of the surface phi 1. So how you will get? I bar dou by dou x. Grad means I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of phi 1. Phi 1 means what? X square plus y square plus z square minus 9. So on differentiating, you will get what you will get? I bar dot I bar 1. So here there is no I bar. Just I bar into dou by dou x of entire term, that is 2x only. Dou by dou x of x square is 2x derivative, y square derivative 0, z square derivative 0 and constant derivative 0. Plus j bar into, what is the value? J bar into dou by dou y of the entire term, that is 2y, plus k bar into dou by dou z of entire term, that is equal to 2j. So now grad phi 1 at the point 2 comma minus 1 comma 2. Grad phi 1 at the point 2 comma minus 1 comma 2. That is the normal vector at the point 2 comma minus 1 comma 2. Grad phi 1 means it is a normal vector to the first surface. You fix it. So this is equal, and substituting the values, 2 2's 4i bar, x2 4i bar, plus 2yj bar, that means 2 into minus 1, that is minus 2j bar, plus 2zk bar, that is equal to 4k bar. This is the first vector to this surface. First vector means the vector to the surface of the sphere. Similarly, we find grad phi 2. Grad phi 2 means the normal vector of phi, the second surface, phi 2. That is I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z of, what is the function? Second function, x square plus y square minus z minus 3. So I am operating with I bar into dou by dou x of the entire function, that is 2x. Dou by dou y of entire function, 2y, plus k bar into dou by dou z of entire function. This is minus 1 only. There is no z square term, so it is minus z. That value will give minus 1. So what at this point, then what to calculate? Grad phi 2 at the point 2 comma minus 1 comma 2. So substitute the values. X for 2, 2 2's are 4i bar and minus 2j bar minus k bar. Am I right? 4i bar minus 2j bar minus k bar. This is the second equation. This is the first equation. So we reached the first vector n1 bar and the second vector is n2 bar. Now what we have to do is we have to find the angle between the two surfaces. The angle between the two surfaces is nothing but the angle between the two vectors. The angle between the two surfaces is nothing but angle between the two vectors. So how to find the angle between the two vectors? So I will write here the vectors 4i bar minus 2j bar plus 4k bar. 4i bar minus 2j bar plus 4k bar. One is, so here we have two vectors. One is first normal vector to the first surface, and the second vector is the reference to the second function. Then the angle between the two vectors we have to calculate. For that, I use the formula cos theta is equal to n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. So I'm using this formula. N1 bar, what is the N1 bar? 4i bar minus 2j bar plus 4k bar. The dot product with the second vector, 4i bar minus 2j bar, and this is minus k bar. The second vector is the 2j bar minus k bar by, what is n1 cap? N1 magnitude of n1 bar, that is root of 4 square 16 plus 4 plus 16. Magnitude of n1 bar. Similarly, magnitude of n2 bar. So the magnitude is 16 plus 2 2s are 4 plus minus 1 whole square, that is equal to 1. So now the problem coming to an end. So the dot product of the two vectors, 4i bar dot product with 4i bar 16. I bar dot I bar is 1. I bar dot j bar 0. I bar dot k bar 0. Only we have to see the product of I bar dot I bar, j bar dot j bar, k bar dot k bar, remaining all zeros. So 4i bar dot 4i bar 16 minus 2j bar minus 2j bar, that is plus 4 minus 2j bar dot product with minus 2j bar, minus 2 dot minus 2, that is plus 4 j bar dot j bar 1. Similarly, last one, 4k bar dot minus 1k bar. So what it is? Minus 4 by root 36 into root 21. So 4 cancel. This is equal to 16 by 6 root 21. 16 by 6 root 21. Root 21 is, as it is, root 36. Say 2 3s, 2 8s. So what is the value? 8 by 3 root 21. So this is the cos theta, not theta. Angle, it is not the angle. This is cos theta only. Then what is theta? Theta is equal to cos inverse of 8 by 3 root 21. That is the required solution. Theta is equal to cos inverse of 8 by 3 into root 21. So in this way, you can find the angle between the two surfaces. The angle between the surfaces is nothing but the angle between the two normals. So first find the normal vector to the first surface n1 bar. Similarly, find the normal vector to the second surface n2 bar. Then use the cos theta formula to find the angle between, that is n1 bar and 2 bar. So clearly both are constant vectors. So the formula for cos theta is n1 bar dot n2 bar by magnitude of n1 bar into magnitude of n2 bar. So all on doing the values, so you get the theta is equal to cos inverse of 8 by 3 root 21. So with these three problems and the data on gradient, I conclude my video, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.